adsorption isomers isotherm. देखो लैंगमुइर एब्जॉर्प्शन आइसोटोम के अंदर क्या है? फ्रेंडली एब्जॉर्प्शन आइसोटोम वाज एम्पिरिकल, बट ये एम्पिरिकल नहीं है. ओके, फ्रेंडली के अंदर देयर वाज नो थियोरेटिकल बेस, बट लैंगमुइर के अंदर देयर इज थियोरेटिकल बेस. उसने क्या कर रखा है? फर्स्ट ऑफ ऑल इट इज डिराइव्ड ऑन द बेसिस ऑफ काइनेटिक थ्योरी ऑफ गैस व्हिच इज कॉल्ड लैंगमुइर एब्जॉर्प्शन आइसोटोम. इट इज एज्यूम दैट उन्होंने क्या किया, उन्होंने यहाँ पे इस तरीके से कर रखा है. सपोज हमारे पास ओके ये एब्जॉर्बेंट है, यहाँ पे एब्जॉर्प्शन होने वाला है, बट एब्जॉर्प्शन हुए उससे पहले उन्होंने ये बताया कि सपोज ये जगह पे एब्जॉर्प्शन हो रहा है, इसको हम एब्जॉर्प्शन साइट्स बोलेंगे. क्या बोलेंगे? एब्जॉर्प्शन साइट ओके फील्ड है या वैकेंट है, उस पर एब्जॉर्प्शन हुआ है या नहीं हुआ है, उससे बाजू वाले को फर्क नहीं पड़ेगा. मतलब दे आर इंडिपेंडेंट फ्रॉम ईच अदर. इफ इट इज फील्ड इट डजंट मेक एनी डिफरेंस टू दिस वन, इफ इट इज नॉट फील्ड आल्सो डज नॉट मेक डिफरेंस टू दिस वन. पहली चीज. सेकंड थिंग उन्होंने ये बताया कि जितनी भी एब्जॉर्प्शन साइड है दे आर एक्चुअली आइडेंटिकल टू ईच अदर. सब एक दूसरे जैसे ही है. So these are the two assumptions. First of all, he has made that all sides are identical, and second thing he said all sides are independent from each other. Okay. One more thing he has said कि भाई जब एब्जॉर्प्शन होता है यहाँ से तब उसको हम कंडेंसेशन बोलेंगे. क्या बोलेंगे? ओके. एंड यहाँ पे हमारे पास जो गैस है उसका एब्जॉर्प्शन हो रहा है, एंड जो गैस वापिस जाएगा जो एब्जॉर्ब हो चुका है उसको हम डिसॉर्प्शन जो बोलते थे, उसके लिए उन्होंने वर्ड यूज किया इवापोरेशन. एंड ही सेड दैट कंडेंसेशन एंड इवापोरेशन के अंदर जब इक्विलिब्रियम एस्टैब्लिश होता है, मतलब एट द रेट व्हिच कंडेंसेशन इज टेकिंग प्लेस द सेम रेट इवापोरेशन इज टेकिंग प्लेस, उस टाइम पे हम इसका x by m निकालें. At that time, this was he has assumed. See here, these are the two conditions he has assumed, and then he has gone further. देखो यहाँ, it is assumed that all adjacent sides are equal and it is independent of the neighboring sides. He has considered two processes opposite to each other in the isotherm derived by him. First thing, there is adsorption of gas on molecule on the surface of solid substance. It is known as condensation. And there is disruption of adsorbed gas, and which is known as evaporation. What he has assumed is this. Langmuir assumed that there is a dynamic equilibrium established between the above two processes. In addition, he also assumed that the adsorbed gas process thickness of only one molecule, that means monomolecular layer, is taking place over here. Adsorption. Such an aspect normally it is being taking place in chemical adsorption. The Langmuir adsorption isotherm can be derived and can be shown in the sort of a following formula. And the formula is Xm equals to Ap upon 1 plus Bp. As we know, Xm is the adsorption of gas per gram of adsorbent, as seen earlier also. Now there are two cases which we can discuss. Suppose this gas is taking place at low pressure. At low pressure, the 1 plus Bp value is such like that the value of Bp can be neglected in comparison to 1. At that time, Bp is much lower than 1. That means 1 plus Bp is equal to 1 only. At that time, if we replace this by 1, then Xm becomes Ap. That means X by M is directly proportional to pressure. So when the pressure is low, X by M is directly proportional to pressure. Correct or not? And when the pressure is high, this again 1 plus Bp value will be changed in such a way that 1 is very much negligible compared to Bp. That means 1 plus Bp, you may write is equivalent to Bp only. But at that time, X by M becomes Ap upon Bp. Bp gets cancelled, so X by M equals to A by B, which is a constant. Hence, at higher pressure, the adsorption will be remain almost which we have already seen earlier in earlier diagram. Correct or not? Now, This is explanation of langmuir. To determine langmuir के अंदर दो values a and b use की गई है ऐसे constant. उसकी वैल्यू डिटरमाइन करनी है कांस्टेंट की वैल्यू. देन x by n equal to ap upon 1 plus bp can be rewritten like this. m by x equal to 1 plus bp upon ap. उसको इन्वर्ट कर दो. And 1 plus bp upon ap को v में राइट 1 upon ap plus bp upon ap मतलब 1 by ap plus b by a. Now that means we are getting x by m equals to 1 upon ap plus b by a, which can be compared with y equals to mx plus c. So y is on x by 1 vertical axis and 1 by p is on horizontal axis. So if we plot a graph m by x versus 1 by p, if you plot a graph like that, let me do that. It's not drawn in your textbook, I am doing it. M by x versus 1 by p. It will be a straight line. And intercept will give you 1 by a and the value of slope equals to I'm sorry, intercept will give you b by a and slope is 1 by a. Why didn't you draw this graph afterwards? You draw that. Let me finish this topic. This equation is also for a straight line basis, that's fine. Friendly adsorption isotherm is shown in the earlier diagram, shows that in the beginning the value of adsorption x by n increases with increasing pressure, and after pressure increases, isotherm tends to become constant. तो दोनों सिचुएशन को फ्रेंडली अच्छी तरीके से एक्सप्लेन कर दे. Actually there are 5 adsorption isotherms out there, but we have to study only 2 of them. Load करो.